the real BIM problem, and the solution. If you work in Revit, you already know this truth. Building a family with 20 different types isn't hard because of the design, it's exhausting because of the hundreds of repetitive clicks in between. Setting up sweeps, binding visibility parameters, checking and unchecking 400 parameter boxes, and assigning materials one by one can drain hours of your time. In this video, I'm not going to give you a rigid tutorial on Dynamo nodes. Instead, I want to show you how I used AI to generate simple, targeted Python scripts inside Dynamo to solve every repetitive bottleneck across a 20 type parametric family, from cleaning external files in the background to automating 2D drafting. Section 1. The design foundation and 3D shape handles. To start, I manually traced 20 unique crown profiles from reference images and saved each into its own profile family. My goal was to host these inside an arched generic model family where I could stretch both the width and height directly in the 3D viewport. Standard reference planes don't give you 3D grip handles for Revit family. To fix that, I built the framework using reference lines, reference planes. This keeps width and height as instance parameters with active 3D shape handles, making it effortless to pull, stretch, and align the trim directly over point cloud data in scantobim projects or adjust it during conceptual modeling. Once the base geometry worked, the repetitive hurdles began. Section 2. AI as a coding assistant for background cleanup. I realized I had 3 problems across all 20 different profile files. The file names were messy, the internal type names were generic, and I had left the reference raster images inside each .rfa, which adds file bloat. Opening and saving 20 files by hand is the kind of busy work we want to avoid. I don't know Python coding syntax, but I know the exact Revit logic I needed. So, I told the AI, I have a Windows folder with 20 different RFA files. Write a Python script to open each file in the background, purge all raster images, rename the internal family type to match the file name, delete duplicate types, and save. If the script threw an error in Dynamo, I simply copied the error back to the AI, refined the prompt, and within a couple of iterations, it ran cleanly. In just 3 seconds, all 20 files were purged, standardized, and ready. Section 3. Automating sweeps, profiles, and visibility mapping. Next came nesting all 20 profiles into the main host family. To get 20 distinct types working properly inside a single family, each type needs its own sweep, its corresponding profile assigned, and a dedicated yes-no visibility parameter mapped to it. Doing this manually is incredibly repetitive. You have to duplicate the sweep, swap the profile, create a new visibility parameter, bind it, and make sure that specific type only displays its own geometry while keeping the rest hidden. If you miss a toggle or bind the wrong profile to a type name, you have to dig through the family types dialog to find where it broke. Instead of grinding through that manual loop, I built just the first base sweep to establish the geometry and parameters. Then, I asked the AI to write a Python script that duplicated the sweep for all remaining types, swapped in their respective profiles, created the matching visibility parameters, and mapped the active toggle cleanly across every single type. One execution, and the entire multi-type structure was configured with 0 manual errors. Section 4. 1. Click material assignment, and 3D floor face placement. Once loaded into the project, changing finishes across 20 types normally means opening the type properties window 20 times. I used another quick script where I just input the family name, the material name, and the parameter. It iterated through the family definitions and applied the finish to all 20 types simultaneously. Then, to showcase the 3D models in the project, I used a placement script. I selected a floor face in Revit, set the spacing, and the script placed all 20 types in a clean, evenly spaced horizontal array directly onto the floor surface. Section 5. Extracting the 2D profile catalog to a drafting view. The last step was preparing the presentation sheet. The 3D trims looked great, but for documentation, you need to show the exact 2D profile cross sections so viewers understand the detail. Revit doesn't allow profile families to be placed directly into legend views as legend components. Instead of redrawing all 20 profiles as 2D detail families manually, I gave the AI one last task. Read the closed loop curves from the 20 different Revit family files in my folder and draw them as detailed curves in a drafting view in a 5-column grid with their type names underneath. I hit run. In the drafting view, I got the dimension-ready 2D catalog grid that I could drop straight onto my sheet. Outro. Practical advice for BIM professionals. The key takeaway here is that you don't need to spend months learning programming syntax to automate your Revit bottlenecks. You already know the BIM logic, the parameters, and the exact manual steps that take too long. Break down your workflow into simple steps, explain the constraints clearly to an AI tool, paste the code into Dynamo's Python script node, and iterate. It turns hours of manual production tasks into a few seconds of execution. Let me know in the comments what repetitive Revit tasks you find most frustrating. Thanks for watching. Don't forget to check out my other videos for more point cloud workflows. If you need to digitize a physical space, we, Synthesis VDC, can help. Based right here in Chennai and serving all of India, our 3D scanning services are perfect for architects, MEP professionals, wedding designers, and more. We specialize in delivering accurate 2D CAD drawings, general 3D models, 3D Revit models, and custom family creations. Along with those models, your deliverables will also include the point cloud files hosted in a cloud-based viewer, allowing you and your team to easily explore the scanned space from anywhere. Check out the website linked in the description below, or contact me directly for pricing on your next project. See you in the next one.